Imagine a warship so large it's essentially a floating city, armed with cutting-edge technology meant to revolutionize naval warfare. The U.S. Gerald R. Ford C-78 was hailed as the world's most advanced and powerful aircraft carrier, a $13 billion gamble to secure U.S. naval supremacy for the 21st century. This first-in-class supercarrier, the largest ever built at over 110,000 tons, promised to transform naval warfare with its new capabilities. But achieving greatness has not been smooth sailing. In this documentary, we explore how the Gerald R. Ford's groundbreaking innovations also brought serious challenges, how those flaws impacted its mission, and what's being done to fix them. It's a story of high-tech ambition, early setbacks, and determined solutions, a problem-solution journey for the U.S. Navy's crown jewel. From the moment it was conceived, the Gerald R. Ford was designed to be unlike any carrier before it. It is the first new U.S. carrier design in over 40 years, intended as a quantum leap beyond the venerable Nimitz class. At its commissioning in 2017, it was touted as the world's largest aircraft carrier and the most technologically advanced, most lethal combat platform in the world, in the words of its program executive officer. This giant warship spans 1,106 feet lift flight deck that dwarfs 3 football fields. It's packed with innovations, 23 new technologies in total, aimed at boosting combat power while reducing crew workload. The Navy envisioned a carrier that could launch more aircraft, faster and more efficiently than ever before, all while operating with a smaller crew and lower lifetime costs. One of the Ford's most significant advantages is its increased sortie generation rate, essentially the number of aircraft missions it can launch and recover in a day. Thanks to its new systems, the Ford class was designed to conduct 30% more sorties than a Nimitz-class carrier, achieving up to 160 flights per day under combat conditions. This high-tempo flight operations, combined with advanced sensors and weapons, would give the U.S. Navy overwhelming air power in any conflict. At the same time, automation and better design would allow the Ford to operate with about 20% fewer crew, saving manpower and cost over its 50-year service life. By all measures, the Gerald R. Ford was a bold step forward, a marvel of engineering meant to keep the U.S. Navy 2 steps ahead of any rival. To deliver these performance gains, the Gerald R. Ford introduced several revolutionary technologies that set apart from previous carriers. These core innovations include the new unmatched catapult system, advanced arresting gear, nuclear reactor design, and dual-band radar, among others. Each represents a major leap in carrier capability, and each was crucial to the Ford's promise of greater power and efficiency. Perhaps the most talked about innovation is EMALS, the electromagnetic aircraft launch system. This replaces the old steam-driven catapults that have launched carrier aircraft since the 1950s. Instead of explosive steam power, EMALS uses electromagnetic propulsion, essentially a giant linear electric motor, to hurl aircraft off the deck. The benefits are game-changing. EMALS can produce a smoother, more controllable acceleration, putting less stress on aircraft frames while still delivering the necessary launch energy. It's also highly flexible. The system can be tuned to launch everything from heavy fighter jets to lightweight unmanned drones, something steam catapults struggled with. By eliminating the need to generate and store steam, EMALS frees up space below decks and reduces the extensive plumbing and maintenance that steam cats required. The Navy boasts that EMALS will increase reliability and efficiency, allow higher sortie rates, and require fewer sailors to operate and maintain compared to legacy systems. With electromagnetic launchers, the Ford can launch aircraft with digital precision, a 21st century update to the very core of carrier operations. On the other end of the flight deck, bringing returning aircraft to a halt, is another breakthrough, the Advanced Arresting Gear AAG. The AAG is a new high-tech version of the traditional tailhook arresting system that catches landing planes. Developed as the successor to the Mark 7 arresting gear used on Nimitz-class carriers, AAG swaps out older hydraulic systems for digital controls, electromagnetic motors, and energy absorbers. Like EMALS, AAG is designed for greater reliability, safety, and flexibility. It can be tuned to handle a wider range of aircraft weights, from the lightest future unmanned vehicles to the heaviest strike fighters, all while putting less stress on both the aircraft and the ship. The advanced control system also provides built-in health monitoring and automated diagnostics, which should reduce maintenance needs and crew workload. In short, AAG aims to safely recover more types of aircraft with fewer people and less wear and tear, enabling the Ford to turn around sorties quickly. Driving all these new systems and the ship itself is the Ford's next-generation nuclear propulsion plant. The Gerald R. Ford is powered by 2 A1B nuclear reactors, an all-new reactor design that produces significantly more power than the formidable reactors on Nimitz-class carriers. These reactors generate plenty of electricity, at least 25% more than previous carriers, to not only propel the ship's 100,000-plus ton bulk through the water, but also to run energy-hungry systems like EMAL's advanced radars, high-powered sensors, and potentially future directed energy weapons. The nuclear propulsion gives the carrier virtually unlimited range and endurance. It can sail for 20-plus years without refueling, an invaluable trait for global operations. With the Ford class, the Navy essentially overbuilt the power plant to anticipate future needs. These reactors provide the electrical muscle for upcoming technologies like radar upgrades and even electromagnetic weapons or lasers the ship might deploy down the line. Rising above the flight deck on the Ford's distinctive island is a suite of sensors that marked another major innovation: the dual-band radar, DBR. The Gerald R. Ford is the only carrier equipped with this complex radar system, which was originally developed for the Navy's cutting-edge Zumwalt-class destroyers. The DBR is essentially two advanced radars in one. It combines an S-band volume search radar and an X-band multifunction radar, with their data integrated to provide a comprehensive picture of the skies around the carrier. This means the Ford can simultaneously track hundreds of targets, from incoming missiles skimming the waves to high-flying aircraft, with a level of precision and resilience against jamming that older radars couldn't match. Not all of Ford's innovations are obvious from the outside. Deep inside the ship, the Navy also installed advanced weapons elevators, AWEs, high-speed electromagnetic elevators to move bombs and missiles from the magazines up to the flight deck. These replace older hydraulic elevators, and they're significantly faster and have greater load capacity. Faster weapons handling means quicker rearming of aircraft and thus more sorties in less time. In fact, the Ford's new elevators and ordnance handling systems are a key part of achieving the higher sortie rate the Navy advertised. However, with great innovation comes great risk. Integrating so many untested systems into one ship proved to be a daunting challenge. The Navy discovered that pushing the envelope sometimes means hitting unexpected obstacles, which is exactly what happened once the Gerald R. Ford took to sea and tried to make all these advanced technologies work in harmony. No sooner had the Gerald R. Ford been launched than it became clear that new technology can bring new problems. The ship's early years were defined by frustrating technical glitches and underperformance of those very systems that were supposed to give it an edge. One by one, the Ford's headline features, EMAL's AAG, the weapons elevators, and the dual-band radar, revealed significant flaws during testing. The Navy faced a stark reality. Their state-of-the-art carrier was not yet battle-ready, and fixing it would take years. But the story doesn't end with problems. In fact, the saga of the Gerald R. Ford is now entering a more optimistic chapter, finding solutions and making the ship fully operational. Over the past few years, the Navy and its industry partners have thrown an all-out effort at fixing the Ford's troubled systems. Through a combination of engineering tweaks, software updates, old-fashioned troubleshooting, and crew training, the carrier has steadily improved. By late 2022, the Navy finally felt confident enough to send the Gerald R. Ford on its first deployment, a short cruise to work with allies in the Atlantic, something that would have been unthinkable a few years prior.